Cool, thanks everyone. This is very much a Pandas 101 talk. Most of you might be much more advanced than this, but the plan is to help people who are looking to do something a little bit better than a spreadsheet, but who aren't sure how to get started. So I've paired this talk with a repository that contains all the examples that I'm going to talk through, and the test data that's the basis of this presentation. And I'll just note that there are actually a lot of different ways to install Python, manage packages, and run analyses that interact with notebooks. So advanced users can take this with a big grain of salt. But the repository just has a really simple, basic flow for beginners. And so I'm using notebooks. These are files with an IPy-NB extension. They're pretty awesome because they contain documentation and code, and it's kind of a visual and interactive way of running Python scripts and immediately viewing the output. You may also have heard of Jupyter notebooks. They're kind of similar, but they let you run other languages, but I've just used IPython to keep it as simple as possible. And notebooks are handy in some situations, but may not be appropriate for other things, depending on what you're doing. So sometimes I'll use a notebook to develop the core functionality, and then take that out to put it into, say, an API service, and other times a notebook's all you need. So let's get started. The first thing is loading data. As I have a vendetta against spreadsheets, this is loading the data from a spreadsheet. It's super simple. You've got to import pandas, and then we load the spreadsheet, and that just brings the data into something called a data frame, which is like a container. And then pandas gives you lots of great little functions, like there's one called head that shows you the first handful of rows in the table. Filtering is really easy, so you can reduce your data set down. So in my PT data set, I've got routes and directions. So I'm just saying for direction 1, maybe into town, and for route 33, show me that data, and I've filtered it just to show the, I'm using tail just to show the bottom of the table, the last few rows. Simple calculations can be done really easily in place. You can see you've just got a column multiplied by another column and put into a new column, and in my table there, that's been added to the end. Advanced calculations are also pretty simple. You can use Python functions. So here I've got something that's kind of figuring out if it's an AM peak trip, so between 8 AM and 9:15 AM, or a PM peak trip for 5 to 6:15 PM. And yeah, you can just apply that function to your data and add it to a new column again. I'm also filtering here to remove any null values, and once again, printing out. Aggregation is also extremely handy. So here I'm grouping by certain columns. So I want to see per route, per direction, per peak period. And for that, I want to sum my distance from the previous stop and patrons times distance to give me a weighted average in the end. And once again, I'm listing the data out with head, and you can pass in a parameter to head to see more rows if you need more than the usual number. Plotting is also really simple. If you've included the matplotlib library, which I have in the example code, you can easily, here I'm just filtering the data down a little bit. Set index says, hey, this is kind of the basis of my data, and then I'm just choosing a column to plot on. Cool, and finally, maybe you need to give that spreadsheet to someone else, or give that data back to someone else who isn't as cool as you using pandas, so you can put it back to a spreadsheet for them. All right, in summary, check out the GitHub repository if this is going to be handy for you. Other things to check out depending on what you're doing. There's GeoPandas, which kind of takes the power of pandas and lets you do GIS stuff. And I've recently heard about Polars, which is like pandas, but it's in Rust, so it's supposed to be really fast. I haven't used it myself, though. And that's it. Thank you.